Good afternoon. I am Mr. Ish. Thank you for joining me. I was very surprised recently to see a question show up on a standardized exam related to this. One of the US standardized college exams had a question with regards to Fibonacci sequence, or you can call this a Fibonacci series. Why was I surprised? Because I would not have thought something like this would show up on a college entrance exam, simply because this is more related to computer science or discrete mathematics, something you would not normally see in high school, but apparently this concept is being taught nowadays earlier than what I had anticipated. So let's talk a little bit about this. It's a sequence of numbers or a series of numbers that is derived by means of a recursive, now this is an important word here, recursive algorithm. A recursive algorithm applies to a series of steps that are being repeated over and over again, like a loop, kind of like a loop. You're repeating the same step to arrive at a sequence of progressive outcomes. That's exactly what it is in terms of this algorithm, a loop. By means of going through the loop again and again, you're developing a progressive sequence, because that sequence is going to expand or enhance with time, not go backwards. It'll always go forwards. And that right there is the essence of a recursive algorithm. In essence, this series or this sequence goes something like this. You have a certain number, we'll call that A1, the first number, or you can use N1. I'm just using A. It has a value of 1. There's a second number, A2, it also has a value of 1. And now the recursive procedures or the recursive algorithm comes now for those situations where you are looking at A3 or higher. For these or higher. Now that will be the nth step. Will always be equal to the sum of the previous two steps. The outcomes of those previous two steps will give you the outcome of the next step. This will be right here, an minus 2 plus an minus 1. And that right there will give you the third number, the fourth number, fifth, sixth, seventh, and onwards. If this right here is giving you the algorithm or the recursive algorithm, how do you go about determining a certain number in this sequence? And that's what we look at here in the remainder of this video right over here. What I'll do is create some space and show you how this recursive algorithm works. We've made a little table over here. We'll start plugging in the values. If I'm looking at the first step, that applies right here, A1. We know the outcome by means of this rule or series of rules is that it has to have a value of 1. And we can just use here the term A or the step number. When we're looking at the second step, we already know automatically it must equal to a 1. Now we're looking at the third step, which would be right here, A3. A3 would be here, A3 minus 2, which would be A1 plus A3 minus 1, which would be A2. You'd look at the values of A1 and A2 and you'd add them up. It's always whichever step you're on, the value of that particular outcome is equal to the sum of the previous two outcomes. You're looking at here at A1 plus A2. The procedure here is you're looking here at A1 plus A2. What's the value of A1 and A2? It's 1 plus 1, and therefore your outcome must be 2. So when you're looking at the Fibonacci sequence or the series, the third value is always 2. Now let's look at the fourth. So you're kind of getting the idea of how this works over here. When we're looking here at the fourth one, we're now looking here at this A4 minus 2, which is A2, plus A4 minus 1, which is A3. Now find the values which correspond to those particular steps. A2 had an outcome over here of a 1. A3 had an outcome here of a 2. 1 plus 2 gives you 3. And that gives you the value of the fourth number. The fourth number in the sequence has a value of 3. Now let's look at the fifth number in the sequence. Now you know you're going to do exactly here A5 minus 2 plus A5 minus 1, which is here A3 plus A4. Now look at the value of A3. The third step had a value here of a 2. The fourth step had a value of a 3. 2 plus 3, 5. Or you can just look at the previous two numbers and add them up. Now I'm just removing this out of the way because it's kind of in the way of this table. A6, you know you're going to look at, always it'll be an minus 2 plus an minus 1. Or you can do the other way around, but the outcome is still the same. Here you're going to have 6 minus 2, which is a4 plus a5. What's the outcome here of the fourth step? It's a 3. What's the outcome of the fifth step? It's a 5. 3 plus 5, 8. And you know what 7 is going to be. You can start ignoring this step. It's going to be 5 plus 8, 13. And you know what the 8th step is going to be. 8 plus 13 is 21. The question here we want to look at now, what is a value of the 10th number in this sequence, the Fibonacci sequence? What is it? Well, we've gone up to A8. You know what A9 will be. A9 will be equal to the sum of the previous two. It'll be 13 plus 21. And what's that going to be? It'll be 34. What's A10 going to be? It's going to be the sum of the previous two numbers. It'll be 21 plus 34. 21 plus 34, and that's going to give you 55. If someone were to ask you in the Fibonacci sequence, what's the value of this A10? Well, it'll be 21 plus 34, A55, because this right here corresponded to the A8 step, and this here corresponded to the A9th step. It's the sum of the previous two steps, the 8th step and the 9th step. If I were to ask you what's the A20 number, well, you need to first determine what's the A18th number and A19th number. If I were to say what's the A50th number, then you need to know what's the A48th number and the A49th. It's always the sum of the previous two. But this doesn't tell you much. You still have to go through the sequence of steps, the recursive steps, because you're using a loop. You're always going back previous steps to arrive at the value for the next future steps, the progressive steps. But you still have to know the values of these, so you have to keep going backwards. You keep going through the loop. The interesting thing about computer science and programming is you can program using whatever programming modality like C++ or whatever, and you can come up with this program and it can give you the value of the sequence of any number without having to do all of this mental work, because a computer will do it for you. If you are tested with regards to this on a standardized exam, such as a US standardized exam, maybe like the SAT or something like that, obviously they're not going to give you a number too large. It'll probably come at the max up to A10, because you would have to still work through these steps, and these steps can be time consuming. You wouldn't be asked what's the value of A20 or A30, because it would be too much number of steps to get to that value, because again it's a recursive procedure. You have to do repetitive procedures of the previous steps to arrive at the values of the future steps. And keep this in mind, this right here is a recursive algorithm, which is always for whichever step you're looking at, the value is equal to the sum of the previous two step outcomes. And that right there is the essence of this. You have a value for the beginning A1, you have a value for A2. They're defined. The value for A3 onwards is always equal to AN minus 1 plus AN minus 2, the sum of the previous two from the third step onwards. And that is the Fibonacci sequence and the Fibonacci series. Thank you for watching. Have a great day.